Once we have a lakehouse in place using Delta tables, wouldn't it be great if there was a feature in Azure Databricks that could help us centralize tasks in a pipeline for our Delta Lake? Would I ask the question if I didn't have an answer? Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Let's dive into the mystery of Delta Live Tables, or DLT, not to be confused with the McDLT, which kept the hot side hot and the cool side cool. No joke, go look it up. Anyway, from an analytics perspective, DLT assists us in creating pipelines that work specifically with our Delta Lake to centralize and automate updates to our Delta Lake. We'll unlock clues to the types of data sets that can be created using DLT, like streaming tables, materialized views, and views. We'll discuss DLT pipelines and what they do, and together we'll solve the puzzle of the pipeline perpetrator. Let's start with what Delta Live tables are. By defining transformations declaratively using SQL or Python queries, Delta Live tables orchestrates tasks, manages clusters, and ensures data quality, making the process reliable and maintainable. Imagine it as a sleuth that not only solves the case, but also keeps everything in order, handling errors and maintaining data integrity. There are two main assets that can be created when using Delta Live tables. Let's explore. Streaming tables are the agile agents in our data mystery, processing each record exactly once and ensuring data freshness with low latency. They are perfect for handling continuously growing data sets, making them ideal for ingestion workloads. In this example, we're providing both SQL and Python options to create streaming tables. Materialized views are the seasoned detectives who've already done the legwork. They pre-compute results and refresh according to the pipeline's update schedule, handling changes in input data seamlessly. These views are powerful for tasks like transformations and aggregations, ensuring that data is always ready for quick retrieval. Again, we've provided some examples of how to start these up programmatically. One thing to point out here is that data integrity can be achieved through expectations, which are identified here as constraints in SQL and expect in Python. Views in Delta tables can also be created, but Databricks does not publish views to the catalog. So views can be referenced only within the pipeline in which they're defined. Views are useful as intermediate queries that should not be exposed to end users or systems. Databricks recommends using views to enforce data quality constraints or transform and enrich data sets that drive multiple downstream queries. Now that we know what we can create, let's look at the pipeline and what it can do. A Delta Live tables pipeline is the master plan that coordinates all the work. It contains materialized views and streaming tables, ensuring updates occur in the correct order. The pipeline compares the current state with the desired state, efficiently processing updates to keep the data accurate and up to date. Once configured, a DLT pipeline triggers updates, starts clusters, discovers tables and views, and checks for errors. DLT will even automatically perform maintenance tasks like vacuum and optimize operations within 24 hours of updates to ensure the most performant results. Once again, it's time to put knowledge to practice. Let's open up the DetectoLab 5000 and build a Delta Live tables pipeline. Welcome back, detectives, to the DetectoLab 5000, and we're going to crack the case of Delta Live tables. So let's get started. Now, the first thing that we need to work with here, we're going to work with some baby name data. So I've already ran a process that loads that in here. If you take a look at my Unity catalog, I actually created a new schema object called DLT demo. And under that, I've loaded in a new volume called baby names. By the way, you can, when you're in a catalog, you can create new schemas doing this. You can create volumes under there as well. Once you have a schema, you can go into the different schemas and then create volumes if you want to this way. You could do it programmatically through Python, any of those things. Most important,
most important thing to note is that we got a CSV file that's in here, and that's what we're going to use to load data in, right? So this is the raw data that we're going to load. What we're going to do is once the pipeline executes, it's going to create these streaming tables and materialized views that are going to allow us to create kind of a medallion, a pseudo medallion architecture, so to speak. And that's the next thing that we're going to look at. So we're going to go into this pipeline steps, and you can create pipeline steps, by the way, in a couple different formats. You can do it in SQL. You can use Python as well, but you can't mix them. So if you're going to create Delta Live Table pipelines, pick and choose. I've been working mostly with Python in this, so I thought it'd be just a little refreshing to see some SQL in the view. So I've utilized the SQL. And what we're doing here is we're creating a streaming table, and each one of these kind of represents a layer in the medallion architecture. So the bronze layer is just the raw data. So we're just loading in that CSV file based on, and if you notice here, I have this my catalog, my schema, and my volume, but there's nothing in here. I'm going to actually create parameters in the pipeline to make this a little bit more dynamic. That's the power of parameters, by the way. I want to generalize these as much as possible and then parameterize the heck out of them so that I can change the way the pipeline executes as opposed to going into the notebook and changing the notebook individually. We don't want to mess with code. It's better to mess with the pipeline object itself. So that's what we're going to do. You can also see that in this silver layer, this first materialized view we're using some constraints. Now, this is what kind of builds in integrity into the tables themselves. So we're telling it what to expect or what to look for when it's loading the data into this table. Like, make sure the first name column is not null and that the count of the values is greater than 0, right? Or it'll fail the process. And then we're defining the schema objects, and then we're loading the data in from that raw table, the streaming table itself. And then finally, we're going to create another materialized view from this materialized view, right? This is our silver layer. So the data is clean, but now I just want the baby names from 2021. So very simple process, but it goes through raw data, clean data, and then finally filtered or enriched data. So this is the actual notebook that I want to use with this. The next step is obviously to create the pipeline. I'm going to open this up in a new tab so I can come back to this a little bit later on. But I'm going to create a pipeline, right? We're going to name this pipeline DLT pipeline. And we're going to leave the product edition. And I need to give it a path, right, to the notebook that we're going to use here. So there's the pipeline steps that I've created. So I'm going to use that as my source code. And then I'm going to use my Unity catalog as the landing place for these. I'm going to select the catalog that I have, and the schema is going to be that target schema that I have. The last thing I want to add to this, so the compute, I can alter compute, I can add notifications or emails if I needed to. What I'm going to do now is add these parameters. So if you remember, there was my volume in this. My schema. Which was DLT demo. And then finally, my volume. Ooh. That should have been catalog. And this is baby names. All right. So there's my configuration. I'm going to create this. So it has the source code and everything. And it knows that it should have it. It should identify that. So what I want to do is I want to validate this. So I'm going to do a validation. But in order for it to track the resources, I need to set this up in here. So let me refresh this. and see. You can see now that it says that I'm connected to this DLT pipeline. Let's take a look here. So now I want to connect to it. And now I'm connecting to it. So it should now track the resources. That's what it's waiting for here, is the compute resources and the actual script itself before it can test this out. So we're going to sit here and let the magic of video validate this and make sure everything's properly configured, and then we'll come back and actually execute it and see where all these things land. All right, looks like our validation passed because I can see an actual graph at the bottom. And this is the awesome thing, right? So I set up all the steps in the actual pipeline itself, but now it even defines these for me. I can even get in here and see the schema objects behind this and get all the processes back and forth. So now I can see the streaming table that was created, the baby names. So this updated table, and I'll show the schema for the top baby names. So now that I know that this thing works, I can go back into the pipeline itself and then actually start this pipeline to run. Now that it's validated, I can go ahead and update this. Now what should happen is that it should create these tables now under that volume that I set as a parameterized object. And even though it's going to render the graph here, it's showing me the steps as they're executing. So right now it's loading the data into the streaming table, right? Then it's going to create these materialized views. So it's going step by step in the process. Now keep in mind that the pipeline may not execute in the exact order that you've defined in your statements in the pipeline steps, because it's just declarative. We're just defining them, right, in the notebook. The way the engine works is it knows how to properly execute this. So just keep in mind that it may not execute everything in order as you have listed there. It looks like it created it, so let's take a look. Let's validate our work. We'll go back into the catalog. Now in my DDBS, in this volume, now you can see that there's 3 tables in here, right? So I have my baby names prepared, I have my raw, and I have my top baby name. So if I look at this, now I should be able to at least see the general schema objects associated with this. I can take a look at some sample data in this, right? So this is just a sample, just as sanity checks. I can just take a look and get some information about it. And you can also see the iconology. So this is a materialized view. This is a streaming table. So it even identifies here in the catalog what type of asset it is. So, and since this thing, and now I could go back, now that I know that I got a valid pipeline here, what I can do is I can go back into live tables and then set an actual schedule for this. So let's take a look at the schedule here. So this is running every 1 day, and you can see that there's more options in here. I could have notifications sent to me if it fails. So these are some notifications that I can go and do. There might be some advanced steps, right? So I can set time zone options. I could set this to go every hour if I wanted. That's about the lowest granularity I can set on this. Oh, there's by minute. So every minute. That's pretty real time. That's sometimes 60 seconds is that near real time area, but I can set this to schedule every minute if I wanted to run it. That's what makes streaming tables so nice, is that it's going to recreate this table or refresh the table based on any new data that comes in. And then these materialized views are generated from these streaming tables, which allow me to just get pre-calculated values out of this. So pipelines are great. Now, if I know that data is coming in, I don't have to manually enter this. I know now I have a process that are going to update my Delta tables in near real time if I needed to, or even if I'm running batch operations, I can update these tables daily. So very cool feature in this. When we talk about workflows a little bit later, you'll see how you can take this is part and parcel of what we can include in a workflow. So not only can I include Delta Live tables in as a task for a workflow, but I can build more robust items that aren't necessarily SQL analytics related, right? I can take one of these tables and run it through a machine learning process. So we'll explore that a little bit later, but looks like we got this case solved. We got our tables created. Let's head back to the studio.
As we conclude our thrilling journey through the mysteries of Lakehouse Analytics using Azure Databricks and Delta Live tables, remember that the true power of these tools lies in their ability to create actionable insights with minimal operational hassle. By leveraging Delta Live tables, we can seamlessly manage and automate data pipelines, ensuring that our data is always up to date and ready for analysis. From simplifying development processes with declarative Python or SQL definitions to dynamically scaling resources to demand, DLT empowers us to focus on what truly matters, the business logic. So whether you're ingesting data from multiple sources or implementing real-time processing pipelines, Delta Live tables have got your back, ensuring data quality and operational efficiency along the way. So unlike the McDLT that hasn't been around for decades, you can start using Databricks DLT today. Plus, it's gluten-free. Thanks for joining.